So let's have a look at the wave equation. The most basic one, we have a sine wave. And as I pointed out before, the way that sound is generated, every single sound can be considered to be made up of multiple sine waves. Every single sound in your door, in open space, is made up of sine waves. And so the sine wave is the most important thing ever. So let's have a look at some of these properties. Right, there is an equation that links some of these properties. So how often does the sine wave repeat? Well, that is every time it goes through a complete cycle like that and like that, is how often that happens per second. That's its frequency, and it's measured in hertz, which is basically repetitions per second, right? Now, also we have the wavelength, which is the distance between the repeating parts of the wave. That is its wavelength, lambda. Now, obviously, these must be related as the sine wave moves through the air. If this wavelength is getting shorter, then the frequency will be getting higher because more of those troughs will happen every second. It turns out that this is a completely linear relationship and can be written really easily as the velocity equals frequency multiplied by wavelength. This is the most fundamental equation that there is. That is the wave equation that's worth knowing if you know anything. So what is the velocity? Well, the velocity is actually the velocity of sound in air. So for all intents and purposes, we're going to call it 344 meters per second. And then you've got your frequency and your wavelength. And you can see as your this is going to always remain the same. It's always the same. It's not going to go up. It's not going to go down. Because, unless the only thing that's going to change that is the pressure of the air, which might change if it gets colder or hotter. But if we're just going to have normal conditions, it's round about there. So if the frequency increases, then the wavelength must decrease. So obviously, lower frequency sounds have very big wavelengths. High frequency sounds have very short wavelengths. Obviously, this equation can be rearranged. So we've got the velocity equals frequency times the wavelength. So if we wanted to find the wavelength, it would be the velocity divided by the frequency. And if we wanted to find the frequency, it would be the velocity divided by the wavelength. Nice and easy, which means you can work virtually anything out as long as you know both of them. And you always know the speed of sound, because that is the speed of sound. And so if you know the frequency, then you can work out its wavelength, which is going to be hugely important in the next section.